Right, guys, indices and logs. So for this, you need the logbook open in front of you and page 21. How are we getting on? So, page 21 in the logbook open in front of us, we'll start with the basics. Have a go at this with me. Three to the power 5 multiplied by 3 to the power 2 without using the calculator. What do we get? 3 to the power of 7. Exactly. When you're multiplying them, you add your powers. Have a go at this one. 7 to the power of 4. 6 minus 2, 7 to the power of 4. Right, we'll go with this one. Find A. So don't forget, the answers, the hints for all these are on page 21 in the log. Do you want to take a picture of that? Right. An idea what A is? Let's look at it. So, root 5 becomes 5 to the power of a half. The power of 4 is equal to 5 to the power of A. Then, power raised to power. What do? We multiply. A half multiplied by 4. That's 5 to the power of 2 is equal to 5 to the power of A. Therefore, A is equal to 2. That's it. Alright. Right, we'll go with this one. Solve for A. What do we get? 6 to the power minus 3 obviously you bring that down underneath the line, it becomes 6 to the power 3, yeah? Because when you bring a power down underneath the line, you change the sign, is equal to 1 over 6 to the power of a is equal to 3. Alright? Right, these are too easy, let's make these harder. So, solve for x. What do we reckon? Because there's 5 either side, we can cancel the 5s and simply say 2x equal to 10 divided across by 2, x is equal to 5. Alright? Have a go at this one. Three to the power 2x minus 1 is equal to 27. What do we get? 2. Let's look at, right, what do we have to do? First of all, 27 doesn't work for us. We have to change 27 into 3 to the power 2x minus 1 is equal to 3 to be cubed. You want your base the same. Your base is the same, you can cancel them. 2x minus 1 is equal to 3. 2x equal to 3 plus 1. 2x equal to 4 divided across by 2. X is equal to 2. Right, we go with this. 16 to the power of x plus 1 is equal to 32. Solve for x. Are we going to change the bases now? 2, yeah. So we go with 16 to the power of x plus 1 is 2 to the power of 2 to the power of 4, is it? 2 to the power of 4 by x plus 1 is equal to 32, becomes 2 to the power of. Power raised to power we multiply. 2 to the power of 4x plus 4 is equal to 2 to the power of 5. What happens there? Cancel. 4x plus 4 equals 5. 4x is equal to 5 minus 4. 4x is equal to 1 divided across by 4. X is equal to a quarter. They get a quarter? Right. Let's have a go at this one, so then. Three to the power of x minus 1 is equal to 1 over 81. What you get, Faye? Minus 3. Adam? Minus 3. 3 to the power of x minus 1 is equal to 1 over 81 becomes 3 to the power of 4. That's 3 to the power of x minus 1 is equal to bring up your 3 becomes 3 to the power of minus 4. 3 is cancel. X minus 1 is equal to minus 4. X is equal to minus 4 plus 1. X is equal to minus 3. Stuff, right. Let's have a go at this one. Make these harder. Root 3 by 3 to the power of x is equal to 243 over root 27 to be squared. So obviously we're working with base 3 here, trying to turn everything into base 3. square root of 27 is not 3 to the power of 3, it's 3 to the power of 3 to the power of half. It's the square root over. Right, let's have a little look at it. So, we have root 3 is 3 to the power of a half by 3 to the power of x is equal to 243 is 3 to the power of 5 over the square root of 27 is 3 to the power of 3 rooted, all to be squared. Then 3 to the power of half, base is the same. When you're multiplying, what do we do? We add our powers. So it's a half plus x is equal to 3 to the power of 5 over 3 to the power of 3 to the power of a half, all to be squared. Right, let's work with the right hand side. 3 to the power of 5 over power raised to power we. What do we do? Multiply 3 by a half is 3 to the power of 3 over 2, all to be squared, which is equal to 3 to the power of 5 multiplied by 3 to the power of minus 3 over 2 when you bring it up, all to be squared, is equal to, base is the same, add your powers, 5 minus 3 over 2, 3 to the power of 7 over 2. Base is the same, you add your powers, all to be squared. Power is the power we. What to do here? Multiply 7 over 2 multiplied by 2. 3 to the power of 7 is 3 to the power of half plus x. Cancel your 3's either side. That's a half plus x is equal to 7. X is equal to 7 minus a half. X is equal to 13 over 2. Right, let's do another tough one like that. So, have a go at this one then. They last 1912. They last 19. George. So why don't we change everything in base? Everything is base 2. Anyone get an answer? Right, let's have a little look at it. So, 2 to the power of 2x minus 1, no need to change it. 16 becomes 2 to the power of 4, is it? 2 to the power of 4 over 2 to the power of 3 to the power of a half. All to be squared. Work with the right hand side. That is 2 to the power of 4 over 2 to the power of 3 over 2, all to be squared, which is equal to 2 to the power of 4 minus, multiplied by 2 to the power minus 3 over 2, all to be squared, which is equal to 2 to the power of 4 minus 3 over 2, all to be squared, which is 4 minus 3 over 2, 5 over 2, all to be squared. 2 to the power of 5, power is the power you multiply, and that's equal to 2 to the power of 2x minus 1. Cancel your 2's. You're left with 2x minus 1 is equal to 5, 2x is equal to 6, x is equal to 3. Get 3 out? Good stuff. Few calculator mistakes, I say, guys, do. Right, last one of these we can have a go at. Have a go at this one. Eight to the power of x to the power of x over 32 to the power of x is equal to 4. What you get? Right, let's have a little look at it. So that becomes 2 to the power of 3 to the power of x to the power of x over 2 to the power of 5 to the power of x is equal to 2 to be squared. We all happy with that? 3 to the power of x to the power of x becomes 2 to the power of 3x squared over 2 to the power of 5x is equal to 2 to the power 2. That is 2 to the power of 3x squared multiplied by 2 to the power minus 5x is equal to 2 to the power 2. All 2's, cancel them off. 3x squared minus 5x is equal to 2. 3x squared minus 5x minus 2 is equal to 0. Factorize it. 3x and x, 2 and a 1, minus and a plus. 3x is equal to minus 1, x is equal to minus a third, and x is equal to 2. Did I do that right? 3x by minus 2 is minus 6x plus 1x, yeah. Minus 2. Just factorize it around, is it? That's grand. We get that, fella? Stuff. Right. So, then we have to go about rewriting things. So what I want you to do is, go at this question 1 second. Right, we go at this. This is the most common one that comes up. Right. Don't worry about I for the moment. Just get I out. So if y is equal to 2 to the power of x, see if you can express a and b in terms of y. So this is known as y substitution or u substitution. You want this to look like some form of 2 to the power of x. You want this to look like some form of 2 to the power of x. Right. So, if we do the first bit of this, IA. Express 2 to the power of 2x to make it look like 2 to the power of x. So, we're going to reverse rule number 3 in the indices, the third one down. Another way of saying a 2 to the power of 2x is 2 to the power of x to the power of 2. So we're going to reverse. Jump power raised to power is multiply. We're going to reverse that. So you can reverse the rules as well. So if 2 to the power of x is equal to y, what's this going to be? Y squared. Then part B, 2 to the power of x plus 1. We're going to reverse rule number 1. So what does this become? 2 to the power of 1 by 2 to the power of x. That's 2 by, what's 2 to the power of x? Y. which is 2y. So we now have y squared and 2y. If we then look at II, using, whenever you see hints, so using our answers from the first bit, 2 to the power 2x can now be written as y squared. Minus 5 times, what's 2 to the power of x plus 1? What we figured out was 2y plus 16 is equal to 0. What's this going to be then, Adam? Yeah, off you go. Solve the quadratic and get the values for x. You need to solve for x now, not just y. You must get values for x. Get what they call this. 2 to the power of x equal y. You get your values from y walking out. Do you get values for x and y? What do you get for x and Adam? Right, let's look at it. So, y squared minus 10y plus 16 is equal to 0. Bracket, bracket. Y and y. Minus 8 minus 2. Y is equal to 2. Y is equal to 8. But we figured out at the beginning, we were looking for x, not y. We figured out at the beginning that y is equal to 2 to the power of x. So, if y is 2, 2 is equal to 2 to the power of x. 2 to the power of what? 1. Therefore, x is equal to 1 there. Y is equal to 2 to the power of x. This time y is 8 is equal to 2 to the power of x. We turn 8 into what? 2 to the power of 3 is equal to 2 to the power of x. X is equal to 3. 2's cancel. Right. Have a go at this one. Right, let's have a little look at it. So, I, part A, 3 to the power 2x can be written as 3 to the power of x to be squared, which is y to be squared. B, 3 to the power of 2x plus 1 can be written as 3 to the power of 1, 3 to the power of 1 multiplied by 3 to the power of 2x, which can be written as 3 times 3 to the power of x to be squared, which can be written as 3 times y to be squared. Is that alright? So, with that in mind then, 3 times 2x plus 1 becomes 3y squared plus 26 times y minus 9 is equal to 0. Factorize it. 3y and y. Plus 9 minus 1. 3y is equal to 1. Y is equal to a third. Y is equal to minus 9. We know that 3 to the power of y is equal to 3 to the power of x. 1/3 is equal to 3 to the power of x. 3 to the power minus 1, when you bring up the third, is equal to 3 to the power of x. X is equal to minus 1. Y is equal to 3 to the power of x. Minus 9 is equal to 3 to the power of x. Minus 9 becomes minus 3 to be squared. No, we got to take out a common minus 1. Because minus 3 to be squared is just 9, not minus 9. Minus and in bracket 3 to be squared is equal to 3 to the power of x. I guess that becomes a plus. Did I do that right? I did, yeah. Minus 3 on this side, and that won't work. Right? Can't figure out that one. It won't work because you have a positive 3 on the right and you have a negative 3 on the left. Because it's minus 9. Right. Have a go at this one. Yeah, there's only one answer, x equal to minus 1. The other one doesn't work. Double check the answers there. 4y squared or 2y squared. I'll have to double check myself. Let's have a little look at it. So, right, if we're along the right line, now, which is a good start, because these are one of the tougher bits. If y is equal to 2 to the power of x, 2 to the power of 2x can be written as 2 to the power of x to be squared, which is y squared. B, 2 to the power of 2x plus 1 can be written as 2 to the power of 2x by 2 to the power of 1, which can be written as 2 to the power of x to be squared times 2, which can be written as y to be squared times 2, which is 2y squared. So, I then is 2 times 2x plus 1. No, it's y squared. Yeah, right. Apologies, you're both right. Sorry. That's 2y squared minus 15 times 2x, which is y, is equal to 8. Yeah, no, 2y squared is right. 2y squared minus 15y minus 8 is equal to 0. Factorize it. 2y and y. 8 and 1 minus 8 plus 1. 2y is equal to minus 1. Y is equal to minus a half. And y is equal to 8. Sub it back in. We know that y is equal to 2 to the power of x. Minus a half is equal to 2 to the power of x. Minus 2 to the power of minus 1 is equal to 2 to the power of x. That won't work because we got a negative 2 and a positive 2. Y is equal to 2 to the power of x. 8 is equal to 2 to the power of x. 2 to the power of 3 is equal to 2 to the power of x. X is equal to 3. That won't work. That okay? Right, without the help. You have to do one this time now without the help. So, example 16. Solve for x. 3 to the power of 2x minus 4 times 3 to the power of x plus 1 plus 27 is equal to 0. More than likely, when they give this question to you in the exam papers, most of the time they don't give you the first two steps. So you have to work it out yourself. So that's 3 to the power of 2x minus 4 times 3 to the power of x plus 1 plus 27. So, no helping hand this time, you can figure it out yourself. This is the hardest bit on, well, UA. This is generally the hardest bit on this. So we're here finished. They come up once a year. They don't come up as a single question usually, they'll come up as a hard, a long question, like a question 8 or question 9. It's buried inside of it. We do like a U substitution, or in this case a Y substitution. did we do last time? So the only hard thing about these is when you're doing these ones down here, they don't give you the starting line. It's the exact same as these. It's just generally companies like that, they won't give you the starting line. The rule of thumb is usually y is going to be equal to 2 to the power of x, y is going to be equal to 3 to the power of x, y is going to be equal to 5 to the power of x, or 4 to the power of x. It's all about figuring out what y is. Once you get that, they're all the exact same. So if we look at it, y is equal to 3 to the power of x. So that means y squared is equal to 3 to the power of x to be squared, which is 3 to the power of 2x. So that's y squared minus 4 times 3y plus 27 is equal to 0. Obviously, you can come out here to the side, do all your rough work to figure out what 3x plus 1 and 2x is. So that's y squared minus 12y plus 27 equals 0. Factorize it. Y and y, minus 3 minus 9. Y is equal to 9. Y is equal to 3. Go back up and sub it in, and you got x is equal to 1, and you got x is equal to 3. Yeah? So they're all the exact same. The only bit figuring out is you have to figure out what your substitution is going to be at the beginning. Is that right? That's the only thing how it's different to what we did up here. Right. So the last bit on indices is the UN. So if, what's this? Example 17. If UN is equal to 5 to the power of n minus 140 times 2 to the power of n, show that u to the power of n plus 2 minus 7 times u to the power of n plus 1 plus 10 times u to the power of n is equal to 0. Right, first things first. We have a u to the power of n plus 2, a u to the power of n plus 1, and maybe u to the power of n. We've got to figure out what all those are first of all. So we'll go with u to the power of n plus 2 first of all. U to the power of n plus 2 is equal to what thing we're going to do? Instead of putting in 5 to the power of n, I'm going to put in what this time? 5 to the power of n plus 2, exactly. Minus 140 times 2 by n plus 2. Right, we've got to simplify this first of all before we sub it in. That's 5n by, how will I split these up? 5 to the power of 2 minus 140 times 2 to the power of n by 2 to the power of 2, which is 25 times 5 to the power of n minus 140 by 4 by 2 to the power of n. What are we going to do from there? Last line. Oh, my neck. 25 times 5 to the power of n minus 140 times 4 minus 560 times 2 to the power of n. Alright? Right, I want you to do then for me, get me un plus 1. Off you go. Because in our equation, we have un plus 2, un plus 1, and maybe un.
That's your equation for n plus 2.
Yeah, so this is un plus 2, the final. That's what we're going to sum in when we simplify. We're going to sum it in up here. That's what our starting with. they told us un to the 5n minus 140 times 2 to the power of n. So I want you to figure out literally what un plus 2 is. Right. So for un plus 1, that's 5 times n plus 1 minus 140 times 2 to the power of n plus 1, which is 5 times 5n, 5 to the power of 1, minus 140 times 2 to the power of 1 by 2 to the power of n is equal to 5 by 5 to the power of n minus 140 times 2 is minus 280 minus 280 times 2 to the power of n. Is that what we got? Right. We then got to put it into our equation. So our equation was, they want us to show that u to the power of n plus 2 minus 7 times u to the power of n plus 1 plus 10 times u to the power of n is equal to 0. So u to the power of n plus 2, we figured out is 25 times 5n minus 560 times 2n minus 7 times un plus 1, which was 5 times 5 to the power of n, minus 250 times 2 to the power of n, plus 10 times 5 to the power of n minus 140 times 2 to the power of n. Big long equation. That 250 is supposed to be 280. It is. I can't read me own writing. Thank you. Right. So what we do then is, nothing changed in the first one, 25 times 5 to the power of n minus 560 times 2 to the power of n. Multiplying your 7. Minus 7 times 5 is minus 35 times 5 to the power of n. Minus 7 multiplied by minus 280 plus 1960 times 2 to the power of n plus 10 times 5 to the power of n. 10 multiplied by minus 140 is minus 1400 2 to the power of n. Have I lost anyone so far? No. I'm getting smiles. Well, kind of smiles anyway, so I presume I haven't. So we have 5 n's there, 5 n's there, and 5 n's there. So 25 minus 35 plus 10 is going to leave me with 5n minus 35 times 5n plus 10 times 5n. Then I have minus 560 times 2n plus 1960 times 2n minus 1400 times 2n. They wanted me to show it was equal to 0. With the help of God, if I haven't made a mistake, it is going to be equal to 0. 25 minus 35 plus 10 does leave me with 0 times 5n. Minus 560 plus 1960 minus 1400 does leave me with plus 0 times 2n, which is equal to 0, therefore. Simple. Right, have a go at one of these before you jump onto logs. So these have only come up like once every 3 or 4 years. They're not that common at all, but we'll still do them just in case. Where's my Yoki? There it is. Example 18. Same as the last time. UN is either 2 to the power n plus 3 to the power n. Figure out what UN plus 1 is and UN plus 2. So that's what I did up there. UN plus 2 and UN plus 1. That's all I just need to do first. Figure out what UN plus 1 is and figure out what UN plus 2 is. This one's slightly easier. And then worry about your equation. Right, let's have a little look back at it. So un is equal to 2 to the power of n plus 3 to the power of n. Un plus 1 is equal to 2 to the power of n plus 1 plus 3 to the power of n plus 1, which is 2 to the power of 1 by 2 to the power of n plus 3 to the power of 1 by 3 to the power of n, which is 2 times 2 to the power of n plus 3 times 3 to the power of n. Un plus 2 is 2 to the power of n plus 2 plus 3 to the power of n plus 2. 2 to the power of 2 by 2 to the power of n plus 3 to the power of 2 by 3 to the power of n. 4 times 2 to the power of n plus 9 times 3 to the power of n. That's a good start there. Right, then u to the power of n plus 2. So that's 4 times 2 to the power of n plus 9 times 3 to the power of n minus 5 by 2 times 2 to the power of n plus 3 times 3 to the power of n plus 6 times 2 to the power of n plus 3 to the power of n, and we have to show that's equal to 0. We all okay so far? 4 times 2 to the power of n plus 9 times 3 to the power of n. Minus 5 by 2 is minus 10 times 2 to the power of n minus 15 times 3 to the power of n plus 6 times 2 to the power of n plus 6 times 3 to the power of n. Highlight everything that's the same. 2n, 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 3n, 3n, and 3n. That is 4 minus 10 plus 6, which is 0 times 2 to the power of n. And then 9 minus 15 plus 6 is 0 times 3 to the power of n, which is equal to 0. Therefore, true. You all happy? Right, a few of those in the homework again then tonight. Right, logs. Same page on our copybook. Write the following. The log of 36 to the base 6 is equal to 2. Write that in form A is equal to B to the power C without using the calculator. The hint for this is the most important rule on the logbook table is the top right corner one. The one in the very top right corner, most important rule in the logbook when it comes to using logs. It's the one you're going to use to get you out of trouble 99% of the time. Ax is equal to y is equal to the log of a, the log of y to the base a is equal to x. This is the important rule. A to the power of x is equal to y. And it can be written as the log of y to the base a is equal to x. Right, very simple then, just so we're starting off. When it's in this form, this is a, this is y, and that's x. And literally you just put it right in as they give it back to you. 6 to the power of 2 is equal to 36. Just true. Alright? You just give it back to them like that then. Right, another one of those. I've got this. The log of a to the base 4 is equal to 3 over 2. Expressed in that form. A is equal to b over c. Once again, this is your a, this is your y, and this is your x. So it is 4 to the power of 3 over 2 is equal to 8. We happy with that? Right. That's the basics on how to use the main rule. Let's start going through some of the other rules. So, for example, if I said to you, the log of 3 to the base 2 plus the log of x to the base 2 is equal to the log of 12 to the base 2. Which rule in our logbook will we be using? First, yeah. So use the first rule in your logbook.
Let's see. Can you get me an answer for x? Solve for x.
So the log of the first rule, you're going to use it in reverse. Alright, the first rule in your logbook, use it in reverse. The left hand side. You should get 4. Any idea, guys? So, because all the bases are the same, using the first rule states that the log of x by y to the base a is equal to the log of x to the base a plus the log of y to the base a. So, because you have a and a, you can turn it into this. So we've 2 and 2. This can become the log of 3 by x to the base 2 is equal to the log of 12 to the base 2. Oh, shit. So as I said, the log of 3 by x to the base 2 is equal to the log of 12 to the base 2. Log 2 either side. 3x equals 12, x is equal to 4. Right, I'll go with this one. Same again, solve for x. The log of x squared to the base 10 minus the log of 2 to the base 10 equals the log of 50 to the base 10. Which rule are we going to use? Which one? In our logbook? Not the first one this time. Okay. Second one, why? Because it's a multiplication and addition go hand in hand, subtraction and division go hand in hand. We'll end up with some form of drag. Should we get x is equal to 10 and x is equal to minus 10? Getting 10 minus 10? So this becomes the log of x squared over 2 to the base 10 is equal to the log of 50 to the base 10. Log 10 cancels either side. X squared over 2 is equal to 50 multiplied across by 2. X squared is equal to 100. X is equal to the square root of 100. X is equal to plus or minus 10. Check it. You must check it with logs. The reason for that is, I know the rule with logs. Can't have a negative log. If you take out your calculator for a second, put the log of minus 10 to the base 10 into your calculator. You should be getting. Put in the log of 10, minus 10 to the base 10. So up here, remember now we're solving for x. Minus 10 to the base 10. Should be getting matter, alright? This one is squared, I'm going to in a second now. If you put the log of minus 10 to the base 10 into our calculator, you'll be getting matter. The reason for that is you can't have a negative log. This one, however, does work because it's the log of minus 10 to be squared over 10, because minus 10 to be squared really high. If the squared wasn't there, we couldn't accept x is equal to minus 10 because we get matter equivalent for calculus, alright? Whenever you get a negative figure when it comes to logs, always check. Right, do another one of those. So, have a go at this one. The log of x plus 2 to the base 2 minus the log of x to the base 2 is equal to 3. Little hint, don't forget the very important rule we use to get us out of trouble. Most important rule, top right corner of the logbook. Don't want to see people just cancelling log to base 2. Don't do that. Remember now, that's not log 3 to base 2, that's just 3. Use the rule in the top right corner.
X and that 9 not 2. And X plus 2 over X. Let's have a little look at it.
So, that's the log then of x plus 2 over x to the base 2 is equal to 3. We then use our top right rule. The a to the power of x equal to y is the same as saying as the log of y to the base a is equal to x. We use that rule. As I said, that's going to get you out of an awful lot of trouble. That's x plus 2 over x is equal to 2 to the power of 3. X plus 2 over x is equal to 8. Multiply across by x and x. Gone, gone. X plus 2 is equal to 8x. 2 is equal to 8x minus x. 2 is equal to 7x. X is equal to 2 over 7 is equal to x. You happy with that? Good stuff. Right, have a go at this one then. the log of x squared plus 4 to the base 7 minus the log of x minus 1 to the base 7 equals the log of 3x plus 2 to the base 7. We'll do one more after this and we'll finish up then, guys. We'll leave the rest of the logs to the next day. We'll back row on. Actually, it's gone 25 today. Just changing the base next week and in the real world applications of logs.
We're all along the right line anyway.
Let's look at it. So, what you want? Someone called a question there for me again, will you? Log to the base 7 of x squared plus 4 minus x minus 1 log of 7 3x plus 2. So that is the log of x squared plus 4 over x minus 1 to the base 7 is equal to the log of 3x plus 2 to the base 7. That becomes x squared plus 4 over x minus 1 is equal to 3x plus 2 when your log of 7s cancel either side. That becomes x squared plus 4 is equal to 3x plus 2 by x minus 1. That's x squared plus 4 is equal to 3x squared minus 3x plus 2x minus 2 is equal to, bring over x squared, 2x squared, minus 3x plus 2x is minus 1x, minus 2 minus 4 is minus 6. Factorize it. 2x and x, 6 and 1, no, minus 3 minus 2 plus minus 2 plus 3 plus minus 2 petty minus 2 plus 3, 2x by x, 2x squared, 2x plus 3x minus 4x minus 1x, 3 over minus 2 is minus 6. 2x equal to minus 3, x is equal to minus 3 over 2. X is equal to 2. What do we have to do? Check they work. Minus 3 over 2 minus 1. No, minus 3 over 2 won't work because up here you'll have the log of minus 3 over 2 minus 1 to the base 7, which is minus 5 over 2. If you put the log of minus 5 over 2 to the base 7 into your calculator, you get matter. Alright, always check your answer, especially with any negative ones. So the only one that works there is x equal to 2. Right, last sum of the day, guys, we're about to get. Have a go at this for me. What's this example? This is 7. The log of x plus 2 to the base 2 plus the log of x minus 2 to the base 2 is equal to 5. So remember now, that's not log 5 to the base 2, that's just 5. See if all 3 of them get answers. we all got down around the fairly similar, plus or minus 6. So that's the log of x plus 2 by x minus 2 to the base 2 is equal to 5. That is the log of x squared plus 2x minus 2x minus 4 to the base 2 is equal to 5. X squared minus 4 is equal to 2 to the power of 5. X squared minus 4 is equal to 32. X squared is equal to 36. X is equal to plus or minus 6. Minus 6 won't work up here because you end up with log of minus 8. So x is just equal to 6. Minus won't work. Good stuff, right? With the back broken on logs, only 2 small but more bits to do with it next week. It was an hour and 45 minutes.